Question number 2. Different radioactive isotopes emit different types of nuclear radiations. Polonium-210 nuclear emits alpha particles and turns into lead, Pb. This can be represented by the equation, that is polonium, it gives lead plus alpha particles. 2.1. What is the value of A in the equation? It is an AO2 question. The student need to use a nuclear equation. We need to find the value of A. The nuclear equations are very simple. If we add these values, the answer must be 210. So A plus 4 is 210, whereas Z plus 2 is equal to 84. We need to find the value of A and the value of Z. So we need to find what will happen here. If this 4 will go on the other side, it will be subtracted from 210, or the student can make the job easy. What is the value of A? If we add 4, it becomes 210. The value is 206. Similarly, the value of Z is, if we take Z as 82 and we add plus 2, the answer is 84. Let's see the value of A and value of Z in question number 2.1 and 2.2. So A is 206, whereas Z is 82. 2.3 is an AO2 question. A strontium-89 nucleus emits a beta particle and turns into an uranium nucleus, Y, and the nuclear equation is given here. The yttrium nucleus is on the right side with a beta particle, and strontium nucleus is mentioned on the left side. We need to find the value of A and Z again in this question. This question is from the nuclear equation. We know that the beta particle has a charge of -1 and mass is 0. When we add these two values, the answer must be 89. When we add Z -1, the answer is 38. We need to find the value of A. When 0 is added, there is no change in the mass. Therefore, A will remain 89. Whereas in Z, we need to substitute a value. If we subtract or take away 1, the answer is 38. So it is very simple. If we take Z is equal to 39, 39 minus 1, the answer is 38. The value of A is 89 and value of Z is 39. 2.4 is an AO1 question, and this question is from radioactive decay and the nuclear radiation. Gamma radiation is another type of nuclear radiation. The student must have the information of electromagnetic spectrum. What does gamma radiation consist of? So it is an EM wave. It is not a high energetic neutron. This is a wrong option. Particles with no charge. These are not particles. Positively charged ions. Gamma radiations are not particles or ions. Therefore, the last option is an incorrect option. The correct option is that gamma radiations are the electromagnetic waves or electromagnetic radiations. So question is, explain the differences between the properties of alpha, beta and gamma radiations. This question is from the structure of an atom, atoms and the nuclear radiations. Let's see the model answer. We need to give the differences between the alpha, beta and gamma radiation. Alpha particle is same as helium nucleus, which is emitted from the nucleus, whereas the beta particle is same as electrons emitted from the nucleus. The gamma radiation is an electromagnetic wave emitted from the nucleus. So alpha particles are like helium nucleus, they are like electrons, and these are waves. Second difference we can count here. Alpha is the least penetrating radiation into the material and can be stopped with the help of paper or skin. Whereas beta is a moderate penetrator into the material, more than alpha but less than gamma radiation, and can be stopped by a thin aluminum sheet. On the other hand, gamma radiation is the most penetrating into the material and can be stopped by a thick lead block. Alpha particle is a strong ionizer because alpha particles have the charge of +2, whereas the beta particle is a moderate ionizer and they have the charge of -1 charge. On the other hand, gamma radiation are the least ionizer because it does not carry any charge. The last difference is alpha particle covers a few centimeters in the air due to the shortest range in the air. Beta particle covers 1 meter in the air and has range less than the gamma radiation but more than alpha particles. Whereas the gamma radiation covers a very long distance in the air and has the largest range in the air.